Hi everyone, this is section 10 and we're going to be picking up with some skills from another book. So this will look a little different than the book that we've been using. Our learning objective right now is we're going to look at place values. This may have been something that you've seen before, but you'll also may need it as you answer questions. And so it's just nice to have a review on this. So when we look at the decimal place in a number and we go to the left of the number, we have the ones place, the tens place, the hundreds, thousands, 10,000s, 100,000s, and millions. If you go to the other side, everything to the right of the decimal has a TH on the end. So instead of a tens place, we have a tenths place, and a hundredths place, and a thousandths place, 10,000th, 100,000th. 100,000. So I've had students ask before, why does it start with the tenths over here instead of the ones? Well, tenths means literally whatever's here would be over 10. So if it was 0.7 something, it would be 7/10. Well, if we had a oneths place, that would be over 1. Well, over 1 is just the ones place. So if we had a oneths place and you put say a 2 there, 2 over 1 is just 2. So there's no need to have a ones place because I can just put it here. So anyway, on the right side it starts with the tenths place, and on the left side it starts with the ones place. So when we're looking at naming or rounding a number, it's important that we know the spots. So for now we're just going to name the spots. So if we were looking at the digit, they really should say the digit, in the tens place, there's a decimal right here. And so in the tens place would be the 2. Ones place, tens place. So that would be the 2. The hundreds place is 3 over. Ones, tens, hundreds. So hundreds place would be the 1 right here. And then the tenths place would be, here's the decimal right here. The tenths place would be 1 to the right of the decimal, so the 8. The thousandths place in this next number, thousandths means tenths, hundreds, thousandths, 3 spots past the decimal, so that would be the 6 in this case. The thousands place goes to the left. Remember, to the right has got the TH, but to the left has just the S on the end. So thousands, ones, tens, hundreds, thousands. So ones, tens, hundreds, thousands. It's just past the comma. The comma starts the thousands period. So this would be 7. And then the tenths place is 1 spot past the decimal, so that would be the 9 in this case. And this is this number has just a 0 in front of the decimal, so we're only looking to the right of the decimal. The 10,000ths place, you've got tenths, hundreds, thousandths, 10,000ths. It's the 4th one over. So tenths, hundreds, thousandths, 10,000ths would be the 6. The tenths place is the first one, so that's the 8. And the hundredth is the next one. So you have your tenths and your hundredths, so 2 is in the hundreds place. Okay, so for the next number, it asks for the number 89,007,125.4, which would be 4/10. In what place is the 9? Well, the 9 is in the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. It's in the millions place. That's a big fat pen. Let's try to get a little thinner one than that. So it's in the millions place. Okay, the 4 then is 1 past the decimal. Here's the decimal. And so 1 past the decimal is the tenths place. For the number 67.3914, the point, that's tenths, hundreds, thousands, 10,000s. So you'd actually say 3,914 10,000s. But they're asking what place is the 9 in. So that would be the hundredths place. First spot is tenths, next is hundredths. The 6 is in the tens place. 1 10. And the 4, we mentioned already, tenths, hundredths, thousandths, 10 thousandths place. Okay. And so now that we know the spots, we can round numbers because we know what places they're talking about. Sorry, scrolling all over the place there. So if you see something that has a 0, 1, 2, 3, or 4 following it, you leave it. But if the number following where you're trying to round to is a 5, 6, 7, 8, or 9, in other words 5 or bigger, we're going to leave it alone. So it says round to the nearest hundred. First of all, let's recognize where the hundreds place is. The hundreds place is here where the 6 is. This is a comma, not a decimal. So 94,637. So the nearest hundreds place is this 6. So we're going to look at that 6 and we're going to say, well, what follows the 6? And the answer is it's a 3. And so let me see if I can get a skinnier pen on this. Hold on a second. Okay, so again, this is a comma right here. And they want us to round it to the nearest 100. So if this is the spot we're trying to round to, this hundreds place, we're going to look to the right of it at this 3, and that's going to tell us whether to leave the 6 alone or whether to round it up. In other words, is 94,637 closer to 94,600, or is it closer to 94,700? That's what we're trying to decide between. Well, since it's 6, 3, which is the 3 is less than 5, it is closer to 94,600. Now, if you had 94,650, that's right in between 600 and 700, but the standard practice is once we hit that 5 or bigger, we round it up. And that was just a decision somebody made at some point. So round 5.3094 to the nearest hundredth. So the nearest hundredth is tenths, hundredths. That's right here where the 0 is. And so we look at that 0 and we look at what's to the right. Well, there's a 9 there. So we need to decide, is 5.3094 closer to 5.30 or closer to 5.31? Well, with this being 309, it's definitely closer to 5.31. And so rounding that would give you approximately 5.31. And rounding this other one to the nearest hundredth would give you approximately 94,600 rather. So now I'm not going to talk through each of these. What I would tell you to do now is to pause the video and do these problems 6 through 11, and then I will write the answers up. But the best thing for you to do would be to pause this, write down what you think the answers are, and then start playing it again and see what the answers are. So here's the answers for those. Hopefully you did okay. And the next thing that we're going to do is we're going to perform some mental arithmetic. What they're saying here is they want you to try to multiply these without using your calculator. You're not going to ever have your calculator taken away in this class, but it is good to be able to do some of these in your head because it's faster. And also they're ones that you should be able to reason through. So I'll kind of give some of my recommendations as I go through. So when I'm looking at 15 times 6, there's a couple different things you can do. 15 times 2 is pretty easy. 15 times 2 is just 30. And 15 times 6 would be 3 times as big. So 15 times 2 is 30. And then 60, 90. Because you're multiplying by 6 rather than 2. So you need that multiplied by 2. So I think of it as 15 times 2 times 3. Another way you could think of it is you could think of multiplying the 10 times the 6 and the 5 times the 6. So 10 times 6 is 60, and then 5 times 6 is 30. Either way, you should get 90. On this, I would definitely multiply the 4 and the 8 first, and then put the zeros on. So 4 times 8 is 32, and then the 2 zeros added on. 25 times 9, you can think of quarters, or you can think of You can count by 25, so 25, 50, 75, 100 gets you, that's 4 quarters, and that gets you to 100. 4 more quarters, so that's 8, would get you to 200, and then another quarter. So 8 quarters, 25 times 8 is 200, so 25 times 9 would be 225. On this, I would use the 0 idea because it's $1.10 times 5. That would just be $5.50. Kind of thinking of the dollar times 5 would be $5, and the 10 cents times 5 would be 50 cents, so 5 and 50 cents. On this one, a couple different things you could do. You could kind of just picture it underneath like this, or 140 is very close to 130. So 130 and 70 would be 200, but then you have that extra 10 from the 140. So 130 plus 70 is 200 plus an extra 10. You're at 210. Here, since we have a 6 and a 4 on the end, that makes a 10. So you have 8, 9, 10, and then another one, you have 11. 11 tens, which is 110. This one's a little harder. I'll put it under like this. I can kind of see it. So I can see that the 9 and the 1 is going to give me 10, 5, 6, 7, 8, 9. And then 6 and 4 is 10. That one's kind of hard to do in your head. I'm not sure why they included that one in your... I mean, it says just you and your brain. I guess it doesn't say you have to not write it down. But so 1,215, if I'm adding that here, that would give me a 10, 7, 8, 9. And then the 2's would give me 4, so 2,490. 1,000 minus 650 I would probably do in parts. So 1,000 minus 500 would give me 500. But I only subtracted 500, which means I need to subtract another 150. So 500 minus 150 is 350. As long as I subtract off the entire 650, even if I do it in bits, it'll still give me the same thing. 10 minus $5 would be $5. So 10 minus 450 wouldn't take away quite as much. It would leave us 550. That's how I would think on that one. 59 minus 34, it's just a subtraction and there's no carrying. So 9 minus 4 is 5. 5 minus 3 is 2. This one I would think of 125 minus 100, but not quite that much. So 125 minus 100 would be 25. So 125 minus only 95 would leave me at 30. Again, there's other ways to think of that. You could also think of 125 minus 95. The 5's would cancel, and then 12 minus 9 gets you the 3. Different ways to do that. 100 divided by 5, if you think of it, if you visualize it like this, 5 into 10 is 2. That goes in evenly, and then there's just space for the 0. So 20 times 5 is 100. 81 divided by 9, or 810 divided by 9 rather. 9 goes into 81 twice, and then again that goes in perfectly, so you just have a 0 on the end. This one, I would just take the zeros off. 12 divided by 2 is 6. So 1200 divided by 200 would also be 6. And same thing here. I would probably think of this as 540 divided by 90. And if you write that in this version again, 9 into 54 is 6. It goes in exactly, and so you don't have anything left over, and so that's just 60. Again, you can use your calculator if you need to, but it's nice to not have to be reliant on it when it's not necessary. So this is section 11 in our book. Section 10 was fairly short. This is section 11. And we're going to have, yet out of another textbook, we're going to talk about proportions and applications of proportions. So the definition of a proportion states that two ratios or rates are equal. So here we have 1 to 4, and that's the same as or equal to 10 to 40. And so we could say the proportion 1 to 4 is the same as the proportion 10 to 40. One that's maybe not, it doesn't always have to be multiplied by 10. So for instance, you could say like 3 to 4 is the same as 75 to 100. But when you look at these numbers, they should be multiplied by the same thing. So 1 times 10 is 10, 4 times 10 is 40. In this case, 3 times 25 gets us 75, and 4 times 25 gets us 100. So now we've got some examples here. So it says we're supposed to write a proportion for each statement. So 5 is to 12 as 30 is to 72 would mean 5 is to 12, write it as a ratio, as, which is the equals, 30 is to 72. 240 miles is to 4 hours. As 300 miles is to 5 hours. Again, if you found out what this was multiplied by, in this case it's multiplied by 1 1/4. But if you found that out, like how many times does 240 go into 300, or what does 240 have to be multiplied by to get 300, the bottom will be multiplied by the same thing. This last one here, -3, oops, kind of ran that into each other. Let me write that more clearly. So wow, I did it again. -3 is to 7, or -3 and 7 are proportional to, just kind of written a different way, are proportional to the numbers -12 and 28. So in other words, -3 to 7 is the same as -12 to 28. So now if we want to know whether two ratios form an equivalent proportion, we should be able to cross multiply and check. So if we want to know if 3/5 equals 9/15, if that's our question, and they're writing it with a little question mark here, let's do it in a different color. So if we wanted to know, are these two equal, then one way we could check it is we could cross multiply. So what we mean by cross multiplying is we take this times this and this times this. If they're equal to each other, then that proportion is true. That is a proportion. If not, then those two ratios aren't equal and it isn't a proportion. So in this case, 9 times 5 is 45, and 3 times 15 is also 45. So yes, this is a proportion. 3/5 is equal to 9/15, or 3 to 5 is the same as 9 to 15. You could also see if they got multiplied by the same thing. So 3 times 3 is 9, and 5 times 3 is 15. Would check that also. But a lot of people like this cross multiplication. It's quick and it's easy. Okay, so on this next one, let's see if we can get a different color. So here, they want to know, is 8 to 4 the same as 10 to 5 1/2? Now, I can look at that, and I'm thinking a lot of you probably can, and see those aren't equal, because 8 divided by 4, 8 is twice as much as 4. This should form the same relationship, and 5 1/2 twice would only be, or would be 11, not 10. But let's use our cross multiplication and see if it works anyway. So are they equal to each other? 10 times 4 is 40. 8 times 5 1/2 would be 44. And those are not equal to each other. So no. So that does not form a proportion. So now we've got another example. It says, it's not written out for us, but they give us the numbers so we can write them in ourselves. It says, determine whether the numbers 2.7 and -5.3 are proportional to the numbers 8.1 and -15.9. So we want to know, is 2.7 to -5.3 proportional to 8.1 to -15.9? So let's go ahead and cross multiply. And 8.1 times 5.3, sorry, I don't know that off the top of my head. I'm going to grab my calculator. So 8.1 times 5.3 gives you 42.93. Now this shouldn't be just close, it should be exact. So is 2.7 times 15.9 the same thing? And the answer is yes, you get 42.93. And I really should put the negatives. This actually is a negative 42.93 and this is a negative 42.93. So now if we want to solve a proportion, that means that we want to find a missing number. So in this case, it says consider x over 20. I know that's hard to read. Consider x over 20 to 3 to 4. What would I have to put here to make this a equivalent proportion or a true proportion? So in order to do that, I'm going to cross multiply and do just the tiniest bit of algebra. 3 times 20 is 60. X times 4 is 4x. And then we're going to divide both sides by 4. And that will give us that 15 is what x needs to be. In other words, if I went back up here and I replaced that x with a 15, it should be true. So 15 over 20 should be proportional to 3 over 4. And we could see, yes, 3 times 5 is 15, 4 times 5 is 20, or I could check the cross multiplication. 3 times 20 is 60, 15 times 4 is 60. Everything works. So that's a really important skill, is this solving a proportion. So we're going to do a couple more. Oh, and also in this book, they have these little skill practices. So if you want to try these little skill practices that are off to the side, the answers are down at the bottom of the page. So in this case, it says determine whether the numbers negative 1.2 and 2.5 are proportional to negative 2 and 5. So you could check that, see what you think the answer is, and then look down here and it'll tell you what that answer is. So again, we have a skill practice here. If you want to try that skill practice and this skill practice, the answers are down here. Okay, so in this case, we're supposed to solve the proportion. And in solving the proportion, if we cross multiply, I'm going to write it over here just so it's nice and big. So 4 to 15 is to 9 to n. If I cross multiply, 9 times 15 is 135. And 4 times n is 4n. So if I want to see if these are proportional, cross multiply and then divide to get rid of the 4 that's in front of the n. And 135 divided by 4. We're not seeing if it's proportional. We're seeing what the n has to be to make it proportional. We get 33.75 is what n would have to be to make that proportional. So in other words, if I wrote 4 is to 15 as 9 is to 33 point, whoops, let me make that a little neater. As 9 is to 33.75, that would be true. So that n could become 33.75, and then you'd have a true proportion. Okay. And they checked it down here. When you cross multiply, you'd get 135 on both sides. Okay, so on this one, a little bit trickier. We've got 0.8 is to negative 3.1. Shouldn't say trickier, just a little bit messier numbers. As 4 is to what? So cross multiply. 4 times negative 3.1 is 12.4. Actually, negative 12.4, sorry. And over here we have 0.8 times p, which would be 0.8 p. And then if I want to know what that p needs to be in order to make this work, I'm going to divide by 0.8 on both sides. And I get that p would have to be, hold on, 12.4 divided by 0.8. That should be, yeah, 15.5. So if I go back up here, then I could, this should work out. If I had 0.8 is to negative 3.1, as 4 is to 15.5. Oh, and I did make an error. This shouldn't be a positive 15.5. I divided, I should get a negative 15.5 here. So 0.8 is to negative 3.1 as 4 is to negative 15.5. And of course that's important. These won't be equal if one is overall negative and the other is positive. So now where would you use proportions? Well, a real common one is miles per gallon in your car. So in this case it says Linda drove her Honda Accord 145 miles on 5 gallons of gas. At the same rate, how far could she drive on 12 gallons? So I'm going to set up a proportion. I'm going to make sure I have it set up with the units in the same places. So 145 miles for 5 gallons would be equal to how many miles, and I'm just going to put an X because we don't know it, for 12 gallons. And that's not anything magical. You can use whatever you want there. You could use M or N or X or A. So when I cross multiply here, but notice that I put miles on top and miles on top here, and I put gallons and gallons. That way we know we are setting it up the same way, and it should be true. So X times 5 gallons would be 5X. 145 times 12 would be 1,740. And then if we want to figure out how many miles she could go on that 12 gallons, I would divide by 5. So 1740 divided by 5 is 348. And so the answer is, at this rate, how far could she drive? She could drive 348 miles on 12 gallons of gas. And it does show that you could set this up in different ways. You could set up the gallons over the miles instead of the miles over the gallons. Or you could set up the smaller gallons to the larger gallons and the smaller miles to the larger miles, or vice versa. You could put the larger gallons to the smaller gallons and the smaller miles to the larger miles. I would say in this situation most people would like this, but any of these would work because any way you have this set up, you're still having 145 times 12 and X times 5. So here, X times 5, 12 times 145, X times 5, 12 times 145, and so on. You get the same cross multiplication in any of those ways of setting it up. Our next example has a cable 25 feet long. It weighs 112 pounds, or 1.2 pounds. So 25 feet is to 1.2 pounds. As a 125-foot cable, so that means the 120-foot cable has to go on top because we had feet over here, or it doesn't have to, but it's one of the ways you can do it, the way that I'm going to set it up. And then on the bottom I'm going to put my pounds, which I don't know. So X pounds. If I cross multiply, 120 times 1.2 is 144. And then if I cross multiply this way, you get 25X. So 144 divided by 25, and you get X equals, dividing here, and X equals 5.76. Then we have a geography application here. It says the distance between Phoenix and LA is 348 miles. On a certain map, this is represented by 6 inches. On the same map, the distance between San Antonio and Little Rock is 8.5 inches. What's the actual distance? So they're saying Phoenix to LA is 348 miles, and that's represented on the map by 6 inches. So now Little Rock to San Antonio is represented by 8.5 inches. I'm going to do 8.5 because that's a lot easier to work with. So 8.5 inches, and they want to know what would be the miles. Now, how do I know to put the 8.5 on the bottom? Because this was the map distance on the bottom. So we're going to put the map distance on the top. This is actual on the top here, so we're going to put actual on the top here. So the pattern we were following was actual distance over map distance. And if we do that in both of the ratios, then we know we'll have our proportion set up right. So cross multiply, 6x equals 348 times 8.5, which is 2,958. And we're going to go ahead and divide by 6. And so 2,958 divided by 6 is 493. So x is 493 miles. And again, if you go back and contextualize that, that is saying that between San Antonio and Little Rock is 493 miles. If it's got the same proportion on the same map as this other one that's been measured. Okay, and then our last example, and don't forget there's these skill practices throughout here if you want to try those out. So our final example here is about a biologist, and he wants to estimate the number of elk in a wildlife preserve. This is kind of one of my favorite ways of using a proportion. It's kind of interesting. So they say that she sedates 25 elk and clips a small radio transmitter onto their ear. The elk returns to the wild, and after 6 months, the biologist studies a sample of 120 elk in the preserve, and of the 120 elk sampled, 4 have radio transmitters. So how many elk are in the whole preserve? Setting this up, you have to be a little bit careful. It's a little bit not as obvious maybe as the other ones. So what she did is she tagged 25 elk out of the entire population, and that's what we don't know. So we don't know out of the entire population what proportion she, or what ratio she, no, proportion was the correct term, what proportion she tagged. But we do know that when she went out and let them roam around and then went back and randomly recaptured them, she had captured 120 this time. And out of those, they found 4 that had the that were tagged with the radio transmitters. Okay, so 4 tagged out of their 120 captured in their bigger capture, and prior we knew that they captured and tagged 25 out of the entire population. So that's how that's set up, and then we cross multiply. This is like our x, so 4x equals 25 times 120, which is 3,000. And then we're just going to divide by 4, and we'll know what our x is, and our x is the 3,000 divided by 4, which is 750. So in other words, when she tagged 25, she tagged 25 out of 750 total in the entire population, because that's proportional to the 4 that she found tagged out of her 120 sample that was redistributed, let the animals wander around. So it looks that the total amount of elk in the area is about 750. And again, this is not perfect, but it's a way for environmentalists and biologists to at least estimate how many animals are in a certain area. So that's it for lesson or section, what was that, 11. And one thing that I do want to point out is there are some problems in the book. If you have not gotten a book yet, you need to get a hold of me and so that I can get you a book for the 0242 class. And let me show you something real quick here. If you have the book and you're looking at this, you'll notice that there's a whole bunch of practice exercises here. And of course, you're welcome to do these, but you have a Connect Math assignment that you can do. So you are not obligated in any way to do this book set of exercises. Now, if you want to look through it, you can. The problem is since we only have this one section out of the book, you don't have the end matter for the book. You don't have the answers to every other odd like you would in most math books. So don't feel like you have to do these practice exercises. Just make sure you go and do your homework in Connect Math. And that's it. We'll see you back with Unit 12 next week.